All right, on to our next unit on solutions. Overview of what we're going to cover in this unit. First of all, we're going to learn about what a solution is. We've talked about solutions before, but we'll get into more detail about what a solution is. We'll also learn about what's called the solution process, or how a solution is made, what actually happens when you put something in something else. We'll learn about solubility, solubility referring to the amount of a substance that can dissolve. And then we'll look at solutions and physical changes, these things called colligative properties, how dissolving something in a substance affects its boiling point or freezing point or osmotic pressure or vapor pressure. So let's start off with a review of what a solution is. So if you recall, solution is a homogeneous mixture. You have something that's made up of more than one thing that has a uniform composition. Particles are too small to distinguish. And so those are some of the properties of a homogeneous mixture or solution. Now there's lots of different types of solutions. Technically, it can be a mixture of any substances that has a uniform composition. So a lot of times we limit ourselves to thinking about just a solid dissolved in a liquid, but that's not always the case. You can have a homogeneous mixture of gases, like what's shown there on the table on page 503. You could have a gas dissolved in a liquid, a gas dissolved in a solid, solid in a liquid, liquid in a liquid. So it could be any combination of different states of matter. All right, here are some key terms. Be sure to keep these straight. It'll have some impact consequences if you don't later on. So just be careful with them. Start off with the substance that is doing the dissolving. This is called the solvent. And then the substance that is being dissolved in the solvent is called the solute. Again, we just saw lots of examples of solutions. Most of the solutions that we will deal with in this class are aqueous solutions, where you have a substance that is dissolved in water. So anytime you see that term aqueous, know that the solvent is water. And then next up, as we talked about before, solubility. There's one definition. Again, the definition I gave you earlier was the amount of a substance that can dissolve. And that amount is, as we'll see later, in grams. How many grams of that substance will dissolve or can dissolve in a certain amount of some solvent? Right, more review. Concentration of a solution. The most common concentration, or the most common way of expressing the concentration of a solution, is through molarity. Molarity, if you recall, has a symbol, big M. That's got to be big M's. Little m means something else, as we'll see later on. All concentrations are ratios, and same goes for molarity. So molarity is a ratio and again, make sure you write this all out in words. I'm not going to write the whole thing, but moles of solute per liter of solution. So we've seen this before, so this should be a review. So let's do a practice problem. And since this is a review, I'll let you do this on your own. Calculate the molarity, or calculate the molar concentration, or sometimes it might just say calculate the concentration. If it just says concentration, usually that means molarity. Calculate the molarity of a solution prepared by dissolving 125 grams of magnesium chloride in enough water to make 1.23 liters of solution. You'll need a calculator and a periodic table. Go ahead and pause the video and do that now. So here's our setup. So I just did it all in one shot. If you broke it up into two steps, found moles first, that's fine. Ultimately, you should get 1.07 molar as your answer. Let's take a look at another example. 50.0 grams of potassium nitrate were dissolved in enough water to make 555 milliliters of solution. Calculate the molarity of the resulting solution. So very similar to the last problem, you got one extra step that you need to take. So go ahead and pause the video and do this now. So once again, there's our setup. The only difference this time is we're given the volume of the solution in milliliters, and that's usually the case because we're not using like huge quantities. And so we need to convert that to liters. Of course, 1,000 milliliters in a liter, so 0.555 liters. Let's take a look at another one. This time we're given the concentration of the solution. So we're given the concentration along with the volume, and we're asked to find grams of solute. Potassium sulfate is the solute. So think about the formula for molarity. Think about what we can use the volume and concentration to find. And then ultimately we need grams of potassium sulfate. Go ahead and do that now. Pause the video. So once again, I've set it up in one step. So first, if you broke this up into two steps, first thing is take the concentration of the solution, multiply by the volume. That will give you moles of solute. Take that moles of potassium sulfate and convert to grams. Notice that both the concentration and the volume both have 2 sig figs. Doesn't matter as long as one of them has 2 sig figs. That'll ensure that our answer then has only 2 sig figs. So those were some of the most common calculations that I myself perform. So anytime I need to make a solution, especially if that last calculation, I need to make a solution of some known concentration and some volume, I need to figure out, okay, how many grams of that particular chemical do I need to make the solution? So I'm doing that type of calculation all the time. The other very common calculation for me involves something called dilution, where you take a solution of some concentration and then you make another solution that has a different concentration. So here's what occurs when you dilute. Diluting, by the way, involves adding more solvent. And again, if this is an aqueous solution, it's water. So you dilute a solution by adding more water. And so something to keep in mind is when you dilute, is the only thing that you are changing is the volume. So what doesn't change? Let's take a look at what happens when you dilute. So let's pick a substance. I have this program here. This is called FETS, the University of Colorado State, I believe. So what do we want to do? You want to do drink mix? We can do whatever you want. We can do drink mix. That's fine because we don't really care about its concentration. So let's add some crystals. Let's see if we can, I'm going to try to show you something here. Let's see. Let's see if you can tell. All right. It says saturated. That's okay. Doesn't really matter what that means. We'll learn about that later. Let's see. All right, we have a concentration, 5.960 moles per liter or molar. Actually, I'm going to reset this just a little bit because I don't want a saturated solution. All right, so let's try this again. So we have 5.556 molar for the solution. All right, so we have a solution, has a certain concentration. And so what if I want to decrease the concentration? I can do so by adding more water. So think about the formula for molarity. If you increase the volume, that will cause the concentration to decrease. Well, when doing so, well, let's do that. Let's add some more water. See if you can tell what happens visually with the solution. Did you notice anything? Looked like it became a lighter color. So that's our visual cue that the solution is more dilute, less concentrated. Now, when I added more water, what happened to the amount of the solute in the solution, the drink mix? Well, nothing. So when you dilute, you do so by just changing the volume of the solution. The amount of the solute does not change, and that is very important, especially for our calculations. So let's take a look. Actually, before we take a look, again, we said visually it looks like the solution is lighter. Lighter meaning dilute. So before it was what, 5.5 something molar? After I add all that water, let's see what happens. Oh, we got a much lower concentration now. So diluting means decreasing concentration. And we do so by increasing the amount of the solvent. So let's take a look. So as I mentioned before, when you dilute, the amount of these solutes before you dilute is the same as the amount of the solute after you dilute. So I'm going to write it like this: mole 1 equals mole 2, the 1 being before diluting and the 2 being after dilute. So how about this then? We just did this a little while ago. How do you determine the amount of moles of a solute in a solution? Well, to get moles, we can multiply the molarity by the volume in liters. Hence, we come up with this formula for a dilution. So M1, the molarity of the solution before you dilute, times V1, the volume of the solution before you dilute. So remember, that is just moles, is equal to M2, the molarity of the solution after you dilute, times V2, the volume of the solution after you dilute. How about this? What is the relationship between V1 and V2? How do they compare? Think about that. Pause if you need to. V2 is bigger than V1. How about this? How are M1 and M2 related? Pause if you need to. M2 is smaller than M1. So make sure that your numbers make sense. So something else to make a note of when using this formula for dilution as opposed to the formula for molarity, your volume does not need to be in liters. So that's why I just put V here. So the volume could be in milliliters. We'll see in our work in a little bit, as long as the V1 and V2 have the same units, doesn't matter what they are. So here I just wrote a little different form, C1 V1 equals C2 V2, C meaning concentration. So it doesn't have to be molarity, but usually we're dealing with molarity, so we're going to do M1 times V1 equals M2 times V2. So let's take a look at some examples. I'll walk you through one and I'll give you some to do on your own. First one here, calculate the molarity of 100 milliliters of 2.37 molar solution after 50 milliliters of water were added to the solution. So again, let's take a look at our formula. I'm going to write it up here just so it's kind of out of the way. So this is anytime you are diluting a solution, start with this formula. So what do we know? So we know the initial concentration of the solution, that's M1. We know the volume of that solution, that's V1. This 50 milliliters, be careful, this is not V2. Let me show you, let me prove it to you that it's not V2. So really what we're solving for here is M2. So let's write an equation isolating M2. Notice you have V1 over V2, so as long as the units are the same, they're going to cancel. So that's why it could be left in milliliters. So we have 2.37 molar times 100 milliliters over 50 milliliters. Now let's think about this. Remember, when you dilute a solution, what happens to its concentration? Its concentration will decrease. Now, if you think 50 milliliters is the final volume of the solution, and you plug that in, what are you going to get? You're going to get, what, 4.74 molar. The concentration increases. That is not correct. So be careful. 50 milliliters is how much water you added to the original solution. So V2 is not 50. By the way, what exactly is V2? V2 is V1 plus what? That's right. So the initial volume was 100 milliliters. To that, you added 50 for a total volume of 150 milliliters. Go ahead and pause the video, punch that up. With something that makes sense, a solution that has a lower concentration, 1.58 molar. All right, letter B, a little bit different. I think I'm going to give you a chance to try this out. How many milliliters of water would need to be added to 250 milliliters of a 3.00 molar solution, so that's your V1 and your M1, to make the solution 2.25 molar? That's your M2. So there's a couple different ways you can do this. Go ahead and pause the video and set it up. All right, so here's one way to set it up. Let's find V2 because we don't know that. And so M1, V1 over M2, so our molarities cancel this time, and we get 333 milliliters. Make sure you understand that this is not the answer to the question. The question did not ask for what will be the volume of the resulting solution. That's what that is. It asks for how much water would have to be added. Well, that's our V2. Remember what V2 is. So we know V2, we know V1. Let's find the amount of water that has been added. So the difference between V2 and V1 is water. In this case, 83 milliliters of water would need to be added to that solution to change its concentration from 3.00 molar to 2.25 molar.